Here we go, exponential. We're 2/3 through this chapter already. Exponential. You remember how I told you a lot of people mix this up with, anybody remember what was last week, which one? Poissons. Remember that? Poisson was how many between a period of time. Remember, I think the example was a toll booth or something? Yeah. And it was like, how many, what's the mean amount of cars that go by in a half-hour period? That's Poisson. 2 cars, 3 cars. You can't have 2.5 cars go by. That's Poisson, it's discrete probability. In continuous, the question would be about the toll booth again and about cars, but the question would be phrased like this. How much time would go by between the next 2 cars at our toll booth? That's the amount of time between an event, and that's exponential. Poisson was how many over a period of time or length or space. This one's all about the amount of time or something, distance, between events. How much time to complete a questionnaire? How much distance between defects in a highway? How much time for a vehicle to arrive at a toll booth? Or to come here to get gas at this tank or whatever. That's exponential. Because think about the time. It could be 5 minutes. It could be 5 minutes, 1 second. It could be 5 minutes, 20 seconds. There's all these times between numbers. And that's why it's continuous instead of exponential. Instead of discrete. Now, the formula is a little different compared to Poisson in that, forget this formula, this is the formula. The difference is 1 minus E. E is always 2.7 blah, 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 right? Everybody knows. E is always. To the power of negative x, whatever you're being asked to find the probability as the x, divided by the mean of the amount of time, or the mean distance, or whatever the mean is in the story. That's the exponent. This calculation you're doing right here will find the probability of any number or less, just like you're looking it up. With this exponential, you're never calculating exactly 3 minutes between cars, or exactly. There's no such thing as a probability of exactly in continuous data with exponential. It's always some number or less, some number or more. It's always a lesser or a more involved. Never exact. Like with the other discrete, what's the probability of 0? What's the probability of 1? But with exponential, there's never what's the probability of 0 or 1. It's 1 or less, 1 or more than 1, less than 1. There's always more or less. And that calculation calculates the or less. If the question's about or more, you just put another 1 minus in front of the 1 minus. Now let me save you time. 1 minus e to the power of negative x over the mean. These two cancel each out. You really only need to calculate that if the question's something about or more. You're already calculating the or more when you do this. This is the or more. And that when you subtract it from 1, that's what allows you to get the or less. And so everybody goes, oh, then I got to subtract it from another 1 to get the or more. But you're going back to what you just calculated. So you might as well just say, if it's or more, these two cancel out. There's the or more. Or more. Got it? Save you time. No, not negative at all. So it's positive e to the power of negative x over the mean.
So that sign is canceled?
That sign is canceled. It's not being subtracted from 1 anymore, because the question is saying or more. Blanky blank or more, blanky blank or higher. To the right of a line of data, a number line, whatever's to the right is being done right here. And that when you subtract it from 1, like this, that makes any number or less with exponential. And so what a lot of people do, especially on Excel, they'll put 1 minus, and they'll maybe do the formula, e 2.7 to the power of, and you just plug in the x. There is an exponential command that we'll talk about in a minute But you don't have to do the 1 minus if you're doing the formula, because just this part is or more. The e to the power of is or more. So, let's get to our example. We have time between arrivals at this full-service gas pump. And it follows an exponential distribution. That's how you know to use exponential. Almost always say in the story that follows exponential distribution. Gives it away what to do, what formula to use. Just like uniforms, always in those problems, it'll say it has a uniform distribution or uniformly distributed. Gives away what formula to use. Says it follows an exponential probability distribution with a mean time between arrivals at this gas pump of 3 minutes. Remember, exponential never has a standard deviation. Matter of fact, the only problems that have standard deviations is the normal distribution. And that's the big hint that should lead you right to, oh, this is a z problem. It's given me a standard deviation, because none of the other ones from chapter 5 and 6 that we've studied have standard deviation but the normal one, the one before that we just studied. And that's the big hint, because it doesn't say normally distributed in that problem. It won't give away which one to use until you, unless you go, oh, it's giving me a standard deviation. That should be the click that says, this is a z calculation. All right? If it's giving you the standard deviation, you know it's a z calculation. So it just gives you the mean time. And it says the words, it follows an exponential probability distribution. And you have everything you need. E to the power of what you're being asked about. It's about to ask you if it usually takes 3 minutes. What's the probability that it will take 5 minutes for the next car to arrive, or 2 minutes, or something like that? 2 minutes or more, or 5 minutes or less, or 5 minutes or more. That's your x, whatever the question's asking about. The mu is the mean. It's always given to you. In this case, 3 minutes. You've got to remember to change whatever you're being asked about. What's the probability the next car to arrive will take 5 minutes or more, or 3 minutes or less? Whatever it is, whatever you're being asked about, make it negative, then divide by the mean, and that's the exponent for e. If it says or more, you're done. If it says or less, you got to subtract from 1. Now that's the opposite of everything we learned in all the other formulas. All the other formulas, we had to subtract from 1 if it said or more. This is the only one that you have to subtract from 1 if it says or less. That's the difference. That's the big difference of this one compared to all the ones from these last 2 chapters. Let's get to an example. Hey, usually it takes 3 minutes for between cars arriving at this full-service gas pump. What's the probability that the next car will arrive in 2 minutes or less? We take the 2 that we're being asked about, make it negative, divided by the mean, which is 3 minutes, so negative 2/3. E is always 2.71828 to the power of negative 2/3. But it said 2 minutes or less, so we subtract that whole calculation of 51% from 100%, or 1. There's a 48%, a little over 48% probability, a little over 48.5% probability of the next car arriving in 2 minutes or less. My question for you is, what's the probability of the next car arriving in 2 minutes or more? And you don't even have to do 1 minus. 5134. Yeah, the 5134 is right there. That little part is the or more. And you'd get the same answer if you did subtract it from 1, but you just added an extra step when the answer, you're going to go right back to the answer you already calculated. So that's what I was trying to get across. Okay, now, with this one, I want to make sure we did Excel. We do Excel, and you know what? We got to do Excel on the z calculation too. I forgot. All right, equals. This is an exponential distribution, so it's EX, it gives you the whole list. There it is, EXPONDIST. If you want to use Excel. But the formula is so easy. It almost takes longer to use Excel than that formula. That's how easy this formula is for exponential. So I go like this, it says X is the first number, which is always whatever you're being asked about. And the example said, what's the probability that the next car coming up to this full service pump will be here in 2 minutes or less? X is 2, comma, lambda. This gets everybody. You've got to take good notes on this one. I'm going to look right in the camera on this one. Lambda is always 1 over the mean. In this case, it would be, what's the mean time? 3 minutes, so lambda would be 1/3. You can literally put 1/3 for the second number, or if you know the decimal, put 0.333 if you want, or something like that. Lambda is always 1 over whatever the mean amount of time is in an exponential problem. So I'm just going to put 1/3, comma. You always use a 1 at the end of exponential distribution. Don't use a 0. With continuous data, Excel, for some reason, doesn't even catch it. But there is no exact probability of 2 minutes. Because there's 2.00001 minutes or 1.99999 minutes. There is no exact. They're so close together, it's always either 2 or less minutes, 2 or more minutes, or more than 2, less than 2. And however you state it, because you're using 2, they're all the same. 2 or more than 2 are the same probability. 2 or less than 2, same probability.
Put it at 0, will it give you an error?
It would, no, it should, but it won't. And it doesn't give you the right answer. So just don't use it, or you're going to get the wrong answer. You want to see what will happen?
Yeah.
I'll put a 0 in. Look at that. But watch what happens when I put a 1 now. And you know what? It may give me. There's the real answer. Isn't that something? That's a flaw in Excel, in my opinion. Always use 1 for continuous data, and exponential would be the perfect one to write a rule. Always use 1 as the last number if you're using the Excel function.
So we say X is what the number is?
X is whatever amount, a number you're being asked about. In this case, it was 2 minutes. The middle number, called lambda, is always 1 over whatever the mean is that's given in the problem. And then the last digit's always a 1. So, look at what we just calculated. That exponential, let me go back to the formula. Exponential distribution for 2 minutes or less. When it usually takes 3 minutes, we turned it into lambda, and we got a 1 on the end because we wanted 2 minutes or less. For if the next car arriving, we usually take 3 minutes between cars at this full service pump. The probability of the next car arriving 2 minutes or less, about a 48.5% chance. Same thing we got on the Excel when we did the formula. If the question says, what's the probability it will be 2 minutes or more? With Excel, you've got to put the 1 minus in front because you're not using the formula. So it's just like all the previous things we've learned, 1 minus. But notice we don't have to change the numbers inside. The numbers in the parentheses in the last chapter had to be the opposite of the question. For this one, you don't have to change the numbers because 2 or less, 2 or more, it doesn't matter. More than 2, less than 2, they're all the same. So just put the 2. You'd be making a mistake to change that number, actually. So the opposite of 46.5% would be, or 48.5%, would be 51 almost and a half percent. So the probability of the next car arriving in 2 minutes or more is about 51.5%.
What is the other answer giving you then?
2 minutes or less.
No, the 0. Like what? I'm trying to figure out what it's even giving you.
It's giving you the probability of everything right around the number of 2 minutes. But we don't.
Which isn't even right.
It isn't right. That's right. It's been that way for, even back when I used to use Lotus before Excel was invented. That was the same error.
Now you just gave your age away. Okay.
That's right. I'll give my real age away. I remember when Lotus first came out. How's that? And I want to tell you, there's hardly any difference between Excel and Lotus. Lotus was the dominant spreadsheet when it first came out. Every business was using Lotus 1, 2, 3. And then Excel came around, slowly took over the whole market. And what's nice about Excel, there's a lot more things you could do with Excel because of all the built-in functions that Lotus 1,